Good morning. So today we are going to start talking a little bit about proving. Okay, we've talked a little bit about it, so we're going to be proving now that triangles are congruent. So let's look at a few things of how you can prove congruencies. Okay, we're first going to talk about side, side, side. Okay, so if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Okay, so this is called side, side, side congruency here. Okay, so I'm just going to try my best to draw two triangles. Okay, one is going to be triangle A, B, and C. The other one's going to be D, E, and F. That is an E, I'm sorry. Okay, so if AB is congruent to DE, okay, and then what? BC is congruent to EF, okay, and then AC is congruent to DF, okay, then we just showed that those two triangles are congruent. So remember how you would write these. You would write these triangle A, B, C would be congruent to triangle D, E, and F. Okay? So remember when we're talking about proving, we have to always write what's given first. Okay? So we're going to do a few that are going to be from side, side, side. Okay? Proving triangles are congruent by using side, side, side. Okay? Alright. So you should have these. It's going to be the first three. So numbers 1 through 3. Alright, give me a second here. Okay, so let's look here. So if we have PQ is congruent to ST. So if PQ is congruent to ST and QR is congruent to TR, okay, R is the midpoint of PS. So what does that mean when it's a midpoint? When R is the midpoint of PS, then that means that these sides here would be equivalent, right? So if R is the midpoint, then it creates that those three are congruent. Okay? So I want to prove that P, Q, and R is congruent to S, T, and R. Okay? So remember, we start with the given stuff. So PQ is congruent to ST. So that is what? Given. Okay? QR is congruent to TR. Okay? R is is the midpoint of PS. So that was also given. Okay, so when R is the midpoint, so now here's my next thing. So if R is the midpoint, then that means that PR is congruent to RS. Okay, by the definition of a midpoint. So now what do we have? We have triangles that are congruent. All three sides are congruent. So now I just showed that triangle PQ and R is congruent to triangle ST and R. By what? Side, 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 because all sides are congruent. Okay? All right, y'all try to do this one for me. Try to do number 2 for me. Okay? So given that JL, so line segment JL and NM are congruent, so JL and NM are congruent. So remember, we write what we have first. Given. K is the midpoint. So if K is the midpoint of JN and LM, so what does that mean? K is the midpoint of JN, so what does that mean? That these two line segments would be congruent, and it's also the midpoint of LM. So these two line segments would be congruent, right? So that was given to us. So by this given to us, then that means that JK is going to be congruent to KN. Okay, by the definition of a midpoint, right? Also, what? LK and KM are going to be congruent by also what? The definition of a midpoint. All right, so now you have all three sides are congruent. So that means that triangle J, K, and L is congruent to what? N, K, and M. By the side, side, side. Because all sides are congruent. All right, y'all try to do this one for me. Number 3. Okay, so given that AC is congruent to AD. So AC is congruent to AD. So that is given to us. This one may not need all 5, I'm sorry. And then CB is congruent to DB. CB is congruent to DB. Okay, what about AB? AB is the same side, so that is the same side for both sides. So remember what that's called. When it's the same, so AB is congruent to AB here, but I'm using it in 2 different spots. So remember, that is the reflexive property. Okay, so now triangle A, B, C is going to be congruent to A, B, D. Because all sides now are congruent. Okay? about is side, angle, side. Okay, we call this one SAS, side, angle, sides. Okay, if two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle okay, then the two triangles are congruent. Okay, so what does that mean? So let me draw my best here. Okay, so here we've got triangle A, B, and C, D, E, and F. So if side AB and side DE are congruent, so if side AB is congruent to DE, okay, if angle B and angle E are congruent, side BC and EF are congruent. So if I have all three of those things going on, then I can say that the triangle A, B, and C is going to be congruent to triangle D, E, and F. So if all three of those hold true, then I'm going to be able to say that the triangles are congruent. Okay, so side, angle, side. Okay. All right, so let's look at these next three. So number 4 here, I have JM. So JM is congruent to LN. So JM is congruent to LN. So JM is congruent to LN. So that was given to us, right? Okay. If angle J, M, and N, okay, is congruent to L, N, and M, so that's this angle right here. So if angle J, M, and N is congruent to angle L, N, and M, so it's given to me, right? I want to prove that J, M, and N, and L, M, and M are congruent. All right? Well, look, we already have two sides that are congruent. I have two angles right here that are congruent. So I have a side, an angle. Well, is this side going to be congruent? And this side is going to be congruent because it shares that side. It shares that side on both of those triangles. So that means that those are congruent. So that means that MN is congruent to MN. So you need to write that down. And that is by, remember, that is the reflexive property. So, therefore now I've got side, angle, side here, side, angle, side. So that means that triangle J, M, and N is going to be congruent to N, or I'm sorry, L, N, and M. Okay, and that is by SAS because it's side, angle, side, side, angle, side. Okay? All right, y'all try to do number 5 for me. Okay, so number 5 here, we have AB is congruent, so AB is congruent to CB here, okay? So AB is congruent to BC, so that is given to us. Okay, so also BD, so BD bisects angle ABC. So if BD bisects angle ABC, so that's given to us, what does that mean if it bisects that? Okay, if it bisects it, remember it splits it in the middle. So that means that these two angles right here would be congruent. So that means what? A, B, and D. So angle A, B, and D is going to be congruent to angle C, B, and D. And that's the definition of a bisect. Because it creates, remember, a bisector creates those two equal parts, just like the midpoint does. Okay, so then what do we have? We have a shared side right here. So that shared side, so DB is going to be congruent to DB. Or you could say BD is going to be congruent to BD. Whichever way you say it. Okay, and that's the reflexive property because it shares it. Okay, so now what do we have? We have side, this angle, this included angle, and a side. I have this side, the included angle, and a side. So now I've got that triangle A, B, and D is congruent now to C, B, and D by SAS, side, angle, side. Okay? All right, y'all do number 6 for me. So take a minute and do number 6. Okay, so what do I have here? I have HI is going to be congruent to JG. It's weird. HI is going to be congruent to JG. So that is given. Okay. HI is parallel. Okay. So what does that mean? That means that HI is parallel to JG. So HI is parallel to GJ, sorry. All right, so what does that mean now? If those two lines are parallel, then what does it say about this angle and this angle? Are they going to be congruent? Okay, so if they're parallel, remember that alternate interior angles, right, are going to be congruent. So that means that I, H, J, so angle I, H, and J, is going to be congruent to G, J, and H. And those are alternate interior angles. Okay, so we got some angles now. Now, do they share a common side? They share that HJ there. So HJ is going to be congruent to HJ by the reflexive property. So now I've got a side, angle, side. Side included angle, side. So that means that triangle G, J, and H is going to be congruent to I, H, and J by side, angle, side property. Okay? So, we've got other ways to learn and talk about proving, but that's where we're gonna talk just about side, 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 and side, angle, side. Okay? So, let's talk about using side, side, side in the coordinate plane. Okay? So, if I was going to use the side, side, side property, I would find the distance between each point. Okay, so you will use the distance formula. So find distance between each given point. So you remember what the distance formula is. It is your x1 minus your x2 squared plus your y1 minus your y2, all of that squared, and then take the square root of it. Okay, determine whether triangle P, Q, and R and triangle X, Y, and Z are congruent. Okay, so here are going to be my points. So at point P, I'm going to be at 5, -4. Q, I'm going to be at -3, 7. R, I'm going to be at 0, 2. Okay, at X, I'm going to be at -2, -1. At Y, I'm going to be at 9, 7. And at Z, I'm going to be at 3, 2. Okay, so we want to show that P, Q, and R is congruent to X, Y, and Z. Okay, I want to show that they're congruent. So that means that PQ is going to have to equal XY. RQR is going to have to equal YZ. And PR is going to have to be equal to XZ. Right? Okay? Or it can be any of them. Okay? However, they are congruent. It may not be in that exact order. Okay? It could be however that we find it. Maybe it's like turned on its side some other way. Okay? So let's try PQ first. So the distance between PQ. Okay? So PQ, so that would be, here's your X and here's your Y. Here's your X and here's your Y. So it would be 5 minus a -3 squared plus -4 minus a 7, all of that squared. So I turn into a plus, so that's 5 plus a 3, which is an 8, 8 squared, which is a 64. -4 minus a 7 is a -11 squared is a 121. So this will be the square root of 185 here. Okay, so now I want to do QR. So we'll have -3 minus a 0 squared plus 7 minus a 2 squared. So that'll be a negative 3 squared, which is a 9. 7 minus 2, which is a 5 squared, which is a 25. So that's going to be square root of a 34. Okay? And then PR, so it'll be 5 minus a 0 squared plus negative 4 minus a 2 squared. So that'll be a 25 plus a 36 and the square root of 61 there. Okay? So now, same thing, we want to find xy here. So xy is going to be equal to a negative 2 minus a 9 squared plus a negative 1 minus a 7 squared. Negative 2 minus a 9 is a negative 11 squared is a 121. 8 is a 64, so that is a 185. Okay, so yz is going to be 9 minus a 3 squared plus a 7 minus a 2 squared. So that'll be a 6 squared, which is a 36 plus a 25. So 36 plus a 25 is square root of 61. And then what? xz. So xz, so that will be a negative 2 minus a 3 squared plus a negative 1 minus a 2 squared. So that's a negative 5, so it's a 25. 3 plus a 9, which is a 34, so square root of 34. Okay, so I have all the same answers, right? Okay, so I have all the same answers, but something's different. So I have PQ is congruent to XY. QR is going to be congruent down here to the XZ. PR is going to be congruent to YZ, right? So PQ is going to be congruent to XY, right? QR is going to be congruent to XZ. Okay? And then what? RP is going to be congruent to ZY. Okay? So let's do this real quick. So this means, I'm going to do some different colors here. So what's going to be congruent? So PQ, okay, YX. So PQ and YX are going to be congruent, okay. QR and what? XZ. So YXZ and P, Q, and R. Okay, so now those triangles, and this is how they're congruent, because remember you have to write it with the sides, okay, and the congruent parts. Okay, so let me write that correctly now for you. So triangle PQR is going to be congruent to triangle YXZ. Okay? Good deal? Alright, if you have any questions, please let me know. Tomorrow we'll review all of this, and then we will have our quiz on Thursday. Alright, have a good day.